Hello everyone, we will be starting today's webinar in just a couple minutes. Well, hello, and thank you for joining today's webinar, DER and Microgrid Management, Customer and Utility Solutions. I'm Chris Freedy, your host for today's event. Before we begin, a few words about the webinar technology. This platform allows our audience to be more involved with the presentation and, more importantly, allows you to watch this event the way you want to watch it. To begin, feel free to customize your webcast console. You can move windows around by dragging on the title bar or resize your windows by clicking on the lower right corner of any window. You'll also notice a toolbar at the bottom of your console. These buttons allow you to open and close widgets on your screen. There will be a question and answer session at the end of the presentation. You can submit your questions in advance via the Q&A button located at the bottom of your console. And if at any time you experience difficulties with the audio or advancing of the slides, simply press your F5 key to refresh your webinar console. A PDF of the slide deck and a link to view the webinar recording will be sent to you via email after the presentation. So with that, I would like to introduce today's presenters, Scott Koehler and Mark Feasel. I'll turn it over to you.
Thank you, Chris. This is Mark Feasel. I lead Microgrid for Schneider Electric in North America. I'm going to start with what we see as the mega trends in the market today, affecting not only North America, but these are global trends. We're coming into a world that is more electric. We see 1.3 billion people without access to energy today, another 1.5 billion with access to only intermittent amount of energy. We've got to be able to bring those people onto the grid, and which of course is going to result in significant load growth. At the same time, in developed countries, we see things like electric vehicle and electrification of ports having a pretty profound impact on the electric grid. So while our grid may be less energy intensive, of the portion of energy, electricity will comprise a greater percentage. A world that's more digitized, 10 times more connected devices than people by 2020. You know, when the grid was invented over around 100 years ago, dealing with electricity, a commodity that is invisible, travels at the speed of light, and dangerous. So it's no big surprise that very few people had the capabilities to be able to interface with electricity, and that truth has maintained itself for most of the last century. But what we see changing is data. Data is demystifying energy, and it's helping many more people understand to a great extent how it impacts their business, how it impacts their operations, and how to work around it in a safe manner. Decarbonize. 86% of investments in power generation through 2040 will be zero carbon fuel. So once again, we see low cost, low carbon fuel sources comprising a greater part of the new generation coming on the grid. And finally, more decentralized. We continue to see a growth in decentralized generation. Will comprise about 12% of generation capacity, and with much of that being driven by increasingly by growth in solar. So what does this mean, this idea of these changes impact upon different shareholders? I'm going to go back to data and just dig into that a little bit. When end users, utilities can better characterize how their grid is running, they have the capability to operate it in different ways. And we see three major trends that are developing. Energy supply being more consumer-centric. What does that mean? It means that the unique nuances of how a specific industry uses energy are being increasingly mandated. So if you are operating a hospital, resilience being a key attribute, reliability extremely high, there is a desire to solve for that versus potentially a college campus where you might rate those things, resilience, cost, sustainability, a little bit differently. We see end users increasingly demanding and solving for the aspects of energy that are most important to them. So it's becoming more bespoke in nature to the consumer. Second, load-centric. Plays to the decentralization. Simply electric generation getting closer physically to consumption as well. And then finally, flexible, modular, scalable, increases in digitization, reductions of cost are allowing us to address the grid in a much more finite way. So perhaps instead of solving for resilience across an entire campus, we're thinking about being laser precise and targeting specific loads within a campus. And the net impact this has is to significantly reduce the cost to improve resilience for what's most important to your operation. As a result of that, there's a different mindset that is now prevailing by the historically passive energy consumers, and that is this idea that of a bit of a balanced scorecard between cost, resilience, and sustainability. 20 years ago, if you desired a more resilient system, you probably needed to invest in a fossil fuel-centric distributed generation play, for example, diesel generation backup. So while you could go solve for resilience for your hospital or data center or military base, it almost always came at the expense of higher costs and worse sustainability. What's happened that's made a pretty profound impact over the last 5 years is that increasingly renewable energy is becoming the core of these decentralized generation scenarios. And what that means is that you can solve in an integrated fashion for resilience, cost, and sustainability and drive an outcome that is balanced to you without sacrificing any one of those vectors. So what that simply means is that maybe 20 years ago, 10 years ago, you weren't putting a microgrid in unless resilience meant a lot to you. Now you can put a microgrid in, drive that resilience, but at the same time not sacrifice sustainability and potentially even increase your cost position by lowering energy costs or making them more forecastable. What are some of the key drivers that I just mentioned? As distributed generation is increasingly renewable in nature, you start looking at levelized cost of energy. So this is a report from Lazard, 2017 report, and I definitely recommend you download it. It's a nice report. They do both unsubsidized and subsidized and what that looks like. So I'm just looking at unsubsidized here, and instead of going through every line, I guess I would just ask you to look at, in general, the trend and the breadth of costs. In the past, you'd have seen the alternative energy, renewable energy costs significantly to the right of the conventional cost. You now see almost 100% overlap. And so you're seeing a world in which renewable energy can be increasingly substituted for conventional generation and do so without increasing the cost of energy to a site, and at the same time, of course, improving sustainability, which we see as increasingly important. So from a cost point of view, it's driving the market. Cost, by the way, when we go out and talk to energy consumers around microgrid, there's no question that cost is still a very prevalent conversation. We can't, in most scenarios, look at a situation in which costs are going to increase dramatically in order to drive that resilience and sustainability. It's no longer the case in most places. You'll notice there's a trend, or there's a bandwidth on each of those. So clearly, different kinds of solutions work in different kinds of markets. Resilience also becoming, extremely important. 2017 saw $16 billion, separate billion-dollar disasters. The total, from a New York Times report that was quoting a government agency, over $270 billion was the cost. So you're looking at a world where, because of climate change and more severe storm, but also because of the way that people are now more dependent upon the grid, due to electricity really being integrated in everything we do, the impacts of these outages are becoming more and more costly. And people are starting to understand a little better, because of data, how it impacts their operations, the safety of their employees, their ability to go serve their customers. It's becoming, once again, a common denominator in the conversations. Finally, sustainability, highlighting just a couple marquee names. And the reason I share these two names is simply because I don't think these are the people you would think about developing and working around microgrids and on-site generation 10 years ago. You now have a scenario where, the Mars company looking to accelerate their carbon efforts, investing over $1 billion, and Philips, the lighting company, simply saying it makes sense from a balance sheet perspective. It isn't simply about us, looking to bolster our brand. It has balance sheet implications. So I think these two things are interesting because they're big global brands. They're not maybe the ones you think about resilience first, thinking about energy in a new way, and at the same time, they're making big bets in the area of microgrids and sustainability. The two quotes along the bottom, 85% of S&P Fortune 500 companies now publish sustainability reports, and then at least 22 companies in the Fortune 500 have announced plans to be 100% renewable energy, a number that we see growing by the day. So I'd like to turn it over to Scott Koehler to talk about how electric utilities and our grid is responding to this change.
Thanks, Mark. That whole description about the value to the customer, what customers are wanting, is causing such significant disruption, and it really is throughout the whole energy value chain. I mean, we are seeing generation, large-scale generation, large-scale coal-fired power plants are being shut down. We're having some renewables. Transmission is operating similar in a lot of ways. But the real investment and the real change and the upheaval in the industry is all around the distribution grid down to the customer. And that is exciting. It's taking an industry that was running pretty straightforward, overbuilt environment in the past, transformers, wire sizes, generation. We overbuilt these. Utilities could afford it. They were ensured to increase usage over time. That was pretty standard for decades. And of course, that's not happening at all anymore. And the industry is really shifting towards efficiency. And you look at the interesting things at the prosumer side, what the customer wants and how they want to engage in the market in new ways. That's going to enable and have investment in a whole host of activities. And you're seeing that today, and it's really just the early stages. But then you start shifting to thinking about the distribution grid and the grid that these customers are connecting to. And how are they going to be able to operate in this environment? How are they going to make the grid more efficient? And what we think about is we really think about situational awareness. Utilities have not had an awareness of the distribution grid for the entire length of the industry. So knowing what's occurring out throughout neighborhoods, a fuse blows, there's no awareness, no telemetry, no way to view that information. Customers start reporting and notifying the utility of outages, and then utilities are reacting. I mean, this is something we've lived with for forever, and that has already been changing. Even a little bit in advance, even in the last decade, about saying, if I can use an operational system that at least lets me look at all available telemetry and look at determining and calculating the current state of anywhere on that grid, not just at the moment, but also forecasting it for the future. An advanced distribution management system in ADMS is one of those examples, bringing in SCADA and other data and analytics. Smart meters, of course, have been helping provide additional sensing at the edge. And you take all that, and then you add DER that causes voltage sags and swells, reverse power flows, overload conditions. You're inherently adding complexity into the grid. So being able to know and predict where grid constraints occur is really becoming the new baseline for how to even operate a grid. And that's really a starting point. And then you start moving into saying, okay, well, if I have this awareness, I can do planning and I can do various things. Well, how can I start optimizing the grid better? And how can I start addressing these reliability constraints? And do this in a way that's not just utility-owned assets, but also interacting with customer-owned assets. And doing this in both planned and, of course, unplanned, unexpected events. Getting an infrastructure in place that does that well, and then thinking about moving that into more economic optimization. Start looking at how that interacts with the markets, addressing customer priorities, utility grid management priorities, essentially maximizing the value across all participants. And really thinking that that is a way to enable a sustainable business model for entities that are owning and operating the grid, and really the rise of the distribution system operator model. And this is converging aspects within a utility that have traditionally been quite siloed. So here I've listed some different solutions or application platforms, and I could have listed these as being different departments within a utility, or even just roles that a utility has responsibility for. So here I have listed an operational system like an ADMS that is optimizing grid assets and looking at grid constraints. And thinking about demand response management, or demand energy management entities and customer care parts of utility, not the operations side, that have had customer programs for demand response, being able to dispatch customer assets for load curtailment, and doing that more on a market-based perspective, and doing that service territory-wide, and doing that in a way that's not even notified or coordinated with the operations of a utility. And how, with increasing renewables being connected to the grid, more customer dynamic assets, grid constraints are increasing to the point where that's not viable anymore. And so how do you start bringing these things together? And distributed energy resource management system, this is something new in the industry. You hear many different terms and definitions for this because it is an evolving thing. But it's really the idea of looking at grid constraint optimization from an operations perspective, but also incorporating any economic optimization and direct control of customer assets, and bringing these things together and managing these types of programs. And ultimately, we look at this and we say this type of approach is about enabling a sustainable utility. It's looking at the traditional things that the utilities manage, like improving system reliability that is getting more complex and difficult, enhancing power quality, efficiency, all the more important for efficiency's perspective, both in the operations and the energy usage. But deferring investments, maybe using the grid in a way that's more optimal that we didn't have the ability to do before, and instead of just building. So a lot of the non-wired alternatives activities are occurring that we'll talk a little bit about. But then start thinking about providing support to the transmission and participating in the wholesale markets. So really this is a way of thinking about individual DER on the grid, some that may even be utility-owned, a lot that's customer-owned, and working and managing these more holistically. But then what is that, and how does that affect microgrids?
Great, thanks, Scott. So what we're going to do really is we're going to, in a way, jump across to the other side of the meter that, of course, is connected in real time with these utilities, and talk about some personas that are emerging, and what are some of the actions that people are beginning to take. And we're grouping those into three main areas. So a grid tide, which in developed countries in North America, for example, is by far the largest class of prosumers, and we're using the word prosumer, professional consumer, that we're seeing. And these are historically passive consumers that are investing in distributed generation, and then some combination of load control, battery energy storage, and other technologies to optimize for that sustainability, resilience, cost wheel that we talked about earlier on. So the mix of what is picked will be dependent upon where their facilities are, Certain technologies such as solar and wind work very well in some geographies and very poor in other geographies. Some parts of the world are exposed to severe weather, others not as bad. The levelized cost of energy in some geographies varies widely. Here in the States, there's a huge shift from state to state on the cost of energy. And so you can imagine that the mix of what is chosen and the optimization scheme that orchestrates those distributed energy resources is tailored to each of the outcomes that those consumers are looking for. But they remain connected to the primary grid. They may continue to get most of their energy from the connected electric utility, but they're also serving some of their needs behind the meter. So that's the grid-tied microgrid. Islandable microgrid. So you begin to see these microgrids emerge where resilience is at an absolute premium. So this would be a military base example. It might be critical community services example. These are sites that are fully capable of islanding. While in grid-tied, most sites are capable of islanding for short periods of time and can do so without sacrificing most of their functionality. When we talk about islandable, these sites are set up to operate independently from the grid for long periods of time. They often have diversified sources of fuel, redundancy within their electrical distribution systems and control systems necessary to operate for an indeterminate amount of time without connection to the grid. And finally, off-grid. These are most often occur in emerging markets where we're looking to bring some energy, we call it access to energy, access to people for the first time or to augment very poor sources of energy they may have. I think the story, as you look at what's the common denominator, is the key role that the DSO, distribution system operator, will play in each of these scenarios. In the off-grid scenario, let's begin with that, there will be a role for someone to tie together or create a network of these separate microgrids. We have seen on sites that we've developed and on case studies we've worked on, the value, it's called the network effect. If you can connect separate networks, there's more value to having more nodes on the network, aiding each other, improving the overall resilience, reducing the cost point. So you see the role of the DSO, being the orchestrator of those microgrids and bringing them together. Islandable utilities generally require a backup from the grid. And in most cases, to get N+1 or N+2 reliability ratings, they're looking for the grid and paying for the grid to be a backup. And of course, in grid-tied, the grid is connected at all times or most times to that microgrid, and it serves a key part of those loads. So what do we see as the evolution? What are the key things going on right now? Number one is standardization. Historically, microgrids have been designed in a bespoke manner, and that's because users had bespoke needs. And microgrids aren't new; they go back decades. But what is new is that increasingly tools, software packages, and approaches are being implemented that create a scenario in which microgrid controls and software are tailored for a customer, but not fully customized for an individual consumer. And the effect this has is to reduce costs, improve commissioning times, and reduce customer service problems over the life of the microgrid. So all of those things end up taking a bunch of costs out for the energy consumer. So no longer is it just the most energy-intense customers that can pay for the incremental cost associated with bespoke solutions, now exposing microgrid-type solutions to a much less sophisticated energy consumer because you're using more commercial off-the-shelf packages. The second thing is that integrated energy outcome, this idea to solve for sustainability, cost, and resilience in one package, simply something that could not have been done 10 years ago. And finally, orchestration. As we look at technologies like cloud connectivity and software as a service to orchestrate microgrids, and what that means is operate them in a sophisticated manner that allows them to do things that they never could have done before. It's very likely that, a hospital today has a backup diesel generation system, probably a bunch of automatic transfer switches, maybe multiple sources of fuel. In the absence of data, those things operate in a very reactive fashion. When we begin to connect those things together, we can begin to orchestrate them and operate them in a much more finite fashion, which means that they're contributing value to the system, not just when an event occurs, like the power goes out, but all the time. So they're solving for economic ends, they're solving for resilience ends, and they're improving the life cycle of the assets that they're connected to. So the orchestration analytics playing a key role in squeezing out the value of a microgrid. So let's dig into that just a little farther. I brought up a chart from the Rocky Mountain Institute, and we're going to provide a link to this chart and report, as well as to the Lazard chart that I referenced earlier on. And what I like about this chart is that it illustrates the value that orchestrated energy resources can have for the consumer, the load-serving entity, the connected utility, and also the wholesale markets. And increasingly, the solutions that we implement are implemented in the market today to solve for resilience, cost, sustainability are checking off various boxes around this wheel. Now, this wheel was specifically meant for battery energy storage. Battery energy storage is extremely flexible and can be applied to many of these different value streams at once. But what you'll find is that any distributed resource, whether it's load control or distributed generation, gas, diesel, fuel cell, whatever it may be, will be able to participate in some of these value streams. And so as consumers are thinking about doing something different with their electric utility, they're having conversations around each of these different value streams, understanding how they could change the nature of their consumption in order to achieve either lower costs. You see, example, you see, demand peak shaving on here. You see rate optimization. You see also incremental value streams such as demand response and ancillary services that these assets could be deployed against with the correct degree of orchestration and integration. So I'd like to share, a specific example of how a consumer here in North America is doing that. But first, I want to touch upon a business model evolution. So we've been talking a lot about technology, but evolution is occurring on the business model side at the same time, and it's just as important. One of the biggest challenges for communities or consumers to implement distributed solutions today is that the cost associated with the capital improvements to improve sustainability, for example, solar or maybe batteries, those costs produce an energy savings that is below the threshold that a consumer would look for their standard return on investment. Deploying distributed solar could result in an ROI that is 7, 10, 15 years. A battery solution that augments that could push that out even farther. So you can imagine that many consumers would look at that and say, wow, I'd love to get more sustainable, and the cost associated with this solar energy appears to be attractive, but if I've got my own capital to spend, then I focus on things 3 years or less. That's a common constraint we've seen. The interesting thing that's going on is we're seeing new players entering the market that are willing to serve the role of alternative energy infrastructure owners and then sell the output of that energy infrastructure to end users, to consumers, in the form of a long-term contract. And what that does is allow the consumer to get the benefits of a microgrid today, and the benefits listed on the right in this specific case that we'll get into: no upfront capital, maybe revitalizing or refreshing some of the infrastructure on site, creating more predictable energy costs, improving reliability, better sustainability, without putting their own capital at play. And so let's look at an example of how that is coming together, and we're going to talk about Montgomery County, Maryland. Montgomery County is a very progressive community that is located right outside of Washington, D.C. It is an incredible place. It's a growing, thriving community. There's over 1 million residents. It is an area where a lot of businesses are investing, and in speaking to leadership of that county, they believe that how they interface with energy is one of the key things that they're doing. They have implemented, they've been, quite frankly, leaders in thinking about how to bring clean, sustainable energy and also low and predictable costs to their community, and to use that as some great competitive differentiation. So you'll see that they're a leader in bringing on distributed solar and other sources. They approached us a few years ago. They've had some challenge with resilience. They had several storms that occurred over a 3-year period that impeded their ability to serve their constituents. Hundreds and thousands of traffic lights going down for a long period of time, affected ability to dispatch police, fire, and ambulance, lack of visibility into what was going on with their grid, when they could expect certain times to be up, which was causing communication challenges with constituents in the county. At the same time, they're an area where they see load growth, right? They're bringing people in, bringing businesses into this. And they began to look for answers. How can I go and achieve some incremental generation, but do so in such a way that's sustainable and improves my resilience? One other note is in the past, an outage could be sustained for about 3 days in their community, at which point they began to run out of the supplies in their day tanks. And there is concern that after a major storm, supply chains of diesel and other fuels could be disrupted and really cause profound challenges in their community. And you have to look no farther than what happened in Puerto Rico to see some of the effects of when that occurs. So, wanting to get ahead of that, they went out to the market and they said, hey, let's talk about some solutions in which we could achieve some of these objectives at once. Montgomery County is a very credit-worthy county. They're AAA credit rating. They can borrow money if they need to borrow money. But when they think about putting their own capital to work, they think about doing things that are, right in front of the community. And if they can work with other people to bring some of this capital from other sources and provide some of these basic infrastructure needs, it leaves more for the other things they want to do. Another challenge that they expressed was that over time, and this is, I think, a challenge that's common to many municipal governments, is that while they can get capital funds to do public works, maintaining those O&M operations and maintenance budgets over the years is very difficult to do. In the case of Montgomery County, they might have a very bad snow year, have to put a lot more salt and snow plows on the street. The money that they have to go do the O&M on their infrastructure just got reduced that year to cover those incremental expenses. So they wanted some innovation around the technology and innovation around the business model. So working together with Duke Energy, non-regulated part, we delivered energy as a service solution to Montgomery County that allowed them to upgrade existing infrastructure, improve sustainability and resilience at 2 different campuses. So this site has 2 different microgrids, one at the public safety headquarters and one at a correctional facility, that will allow them to service those needs, improving the resilience, making sure that they can dispatch emergency services when they need to throughout their community. The microgrid was based in the beginning around solar and CHP. Because it's designed in a modular, flexible way, I think that we will in the future see aspects of the microgrid moving to other sites, as well as integration of other distributed energy resources, such as battery energy storage, over time. What did Montgomery County gain? They got 15 years of guaranteed energy costs, so they fixed their energy price for 15 years. They can now go more than 7 days without any grid support, without reducing functionality to their citizens. They've reduced their greenhouse gases, and they upgraded infrastructure without putting their own money at work. Scott, I'm going to turn it back over to you.
Thanks, Mark. That's such a great example. It's such an interesting example of new energy business models, thinking about the details of what customers and how they interact with their energy, the cost, the sustainability, all those things are such important factors, and more so than ever. And the types of microgrids that will be deployed is only continuing to expand. NWAs, non-wire alternatives are helping spur innovation. Even utilities are deploying some of their own microgrids. Some of that is a learning aspect. Some of that is to run some of their own facilities. And in even cases, starting to look at the grid in new ways and say how a section of a grid could be islanded from the main grid and not de-energized to do some work, but actually keep that section energized while they've been able to isolate the power or the area that needs the work. So the uptime can be improved, and lots of things that are coming, lots of different technology, and lots of investment, lots of new players. So you named some examples of that, but we have equipment manufacturers, electric vehicle manufacturers, thermostat manufacturers, all these different solar, looking to provide value and connect to the grid and have a direct connection to all the assets that they help interact with and offer as a service. All these, of course, inherently are threats to the way we think of traditional utilities, but that's changing. And before I talk about regulations and other things that are part of that process, there's also the aspect of this all sounds really complicated. And this, from a utility perspective, is how do we even get started? Started on and walk down this path. And so I'm trying to, at this point, break down a little bit of ideas about how to think about that, because every utility, utilities all across the globe have different types of regulation, different drivers, different types of customers. Some are more rural, more urban. Some are regulated, deregulated. So you have a whole gamut of requirements and some kinds of somewhat unique constraints. So what we're seeing, and it's this idea that if I'm worried about distributed energy resources impacting the grid, customers owning these assets, maybe having discharging into the grid, how will I even be able to coordinate or understand it? And we really think this is an evolution, and this is a way to start more simple, depending on your needs. Some utilities are doing very complex things initially. Some are doing more simple things initially, but all with a path of how can they get to this end game that we currently see in the future, and what is their role. So what I've referenced here is a way of thinking evolution over time and how that capability is increasing over time, and how to think of this as more from an operating the grid aspect, but also planning it. And so we think initially just modeling the various types of DER. What's the behavior of that asset? What's the size of that asset? What type of controls are on that asset? Is that dispatchable? Is it not? Is it part of some other customer program or new customer program that might be coming in the future with new rate structures? And being able to have a system that understands that, updates that, and do all kinds of planning and what-if analysis associated with it. And to be able to do things that maybe you don't have a complex network model. We think of maintaining a representation of the grid is never 100% accurate. And a lot of utilities may have never used a GIS, a Geographic Information System, for these purposes, these more advanced operational purposes. So maybe work has to be done there. So we think of different starting points that help that. Some cases you think of more of a rule-based approach that says, well, if I understand some telemetry at the feeder head and maybe some other devices that are connected, if I have that, and I generally know the topology, I know where my assets are, and then maybe I can do some basic analysis there that helps me understand what could be done. And then as your model becomes more sophisticated and more detailed, then you can do a much more robust and accurate analysis and optimize at a much granular level. And this leads to understanding DER output, forecasting, so there's weather data integration with third-party entities that may have information about certain assets and how they're behaving or a certain event they're going to be participating in. All this information from an operational perspective just makes the operations of the grid, the visualization is there, the information is there, and the ability to plan in near term and prepare for and be more resilient for activities just becomes more viable. And this also this affects everything related to planning and all different types of operational activities and applications. And then we start thinking of monitoring and more basic control. So how can I get this telemetry? Is this a more traditional utility-owned asset that has maybe a SCADA-type communication to that that's real-time? Or is it smart metering? Maybe the AMI or smart metering infrastructure helps provide data in new ways for operational purposes. And then maybe it is another entity within a utility that maybe is running a demand response program, or maybe it's a non-utility system, a third party that has information about various assets. So all of those things coming together, if that's information that provides telemetry, there's different latencies, there's different reliability of the information, but put some assumptions around those and understand how it starts to affect. And then you start thinking of more simple dispatch controls. So this could be an on-off kind of connect-disconnect type of command. It could be set point changes. Maybe this is more manual, but it allows an interaction with the operations to do that. Understanding what hidden load is. So when the cloud cover comes over and these solar rooftop units are no longer generating instantaneously, what is that load that you weren't seeing before that they were helping feed, and is the utility prepared for that? And you start doing hosting capacity analysis, just starting to look maybe even as a traffic light sort of thing, a green, yellow, red view, feeder by feeder throughout a service territory of if there were more and more connected DER assets, when will that start to cause grid constraint issues? And that's you're going to find some areas that's more of a problem versus others. You're going to find some areas that have a higher penetration already. Is that causing issues? And a lot of these things let you start planning and investigating that. And then you start getting into automated capabilities of dispatching things in a coordinated way. So taking traditional utility assets and then looking at incorporating non-traditional assets, other grid assets. And initially this may be some other utility-owned assets or utility assets that they deployed on behalf of a customer, and how you start testing that. And this is, we listed volt var watt optimization. It's a little more detailed here, but the idea that you're managing voltage on the grid with traditional assets and new assets working in harmony. And then, and knowing that some of them are dispatchable, but some are not, but how will the ones that are not behave? And integrating microgrids in this case. So is that at the point of common coupling, is that being able to dispatch that microgrid that another technology is doing the local microgrid control. And then start looking at how does this start to move to co-optimization, a very interesting new approach to say I can manage grid constraints. I've got an infrastructure in place over time following this path, but how do I start co-optimizing different priorities around economic and grid constraint and customer, and thinking about how those are prioritized, when is the utility involved in that decision? And this could be the case where you may have direct access to the market from customers, but the grid at least is involved in the decision process to say when will this cause an issue or not, or maximizing the value for that customer to be able to sell more energy to the grid that they happen to have at this moment, and the grid could take advantage of if it had this type of approach in place. We think of things that are happening in evolution around some of this. I'll just give some brief examples because they're quite interesting and diverse. But part of it is thinking about the integration. So there's been a lot of research over the last several years, things like evolution of smart inverters. So how does an inverter connect a solar rooftop unit or energy storage device to the grid? And what intelligence does it have? Two-way communications to that asset. What data can it provide? And there's a lot of standards around that. So that's more device communications. But one thing that we saw that was lacking and needs more attention is, I mentioned different enterprise-type entities. These might be cloud-based systems. They might be third-party or utility-owned that are sharing this information. Well, that's not sharing communications that are directly to the device. At this stage, you're saying, I'm talking about a group of assets. I might do this in a way that is, what's the standard for sharing this data? How do we represent that structure and have that be standardized? So there's been a lot of good work around it. NREL's been doing some work in this space. EPRI is doing a lot of development and testing. We've done some interesting things at the National Renewable Energy Lab for testing these out. And EPRI is even doing compliance certification around the IEC SIM 61968 Part 5 that's talking about, for example, a distributed energy resource management system talking to a distribution management system, or talking to a demand response management system, or an aggregator of some kind. And doing it at a level deeper that some standards haven't gone in the past, where it's not just how they interoperate, but example profiles of how those things would be structured. So some good stuff is happening there. More needs to happen. And just quickly on some projects. So Xcel Energy and Austin Energy involved in what we call a hybrid control architecture, where looking at centralized control that a utility has with decentralized. And these decentralized assets could be autonomous, configured to behave a certain way, or might be customer-owned. But how do you start interacting those things together that you can bring those in harmony? And when is it make sense to dispatch a decentralized asset that is configured to behave a certain way? And what is that workflow? How does that workflow work? Central Hudson, part of the New York Rev, really progressive regulations there, looking at applying some energy storage to the distribution grid. And how do you, it's two ways really. It's thinking about how do you bring value to the grid if this is a dispatchable asset, and what are all those use cases, but also the value to the customer. And really the customer is king in all of this, and much more so than ever. And that's really the reason why this whole industry is changing so dramatically. Microgrid integration, so the idea of taking technology that Mark was talking about and then the centralized utility operational systems and integrating those together. And they each, again, the microgrid is working autonomously, has its own microgrid controller logic. But how does that interact with the grid? Again, ensuring value for the customer, participating in the market, but also bringing value to the grid and testing those things out. So that's something that's interesting that's happening. And that's happening in Australia. There are lots of PV, lots of adoption of solar and other things there, so it's a great place to test that. And also in Europe, in the UK, active network management is a really progressive approach to thinking about how you bring in these different assets and deal with load relief and deal with voltage management and load shedding, and basically looking at activating new services and thinking about how we're going to ultimately provide customers with new services and how do we deliver those. So with that, I think we've come to the end of our presentation, and I think we've got quite a few questions. Chris?
Well, fantastic. Thank you, Scott and Mark. We will now open the floor for the question and answer session. And as a reminder, if you would like to ask a question, please use the Q&A feature on the widget bar at the bottom of your console. So the first question we have coming in, I believe here, we'll turn it over to you, Mark. What are some examples of the tools that you mentioned?
Yeah, the tools associated with teasing out insight on the grid, it's really just an explosive field right now. A lot of innovation going on really across the world. I think you could group these into several different kinds of buckets. There is a growing number of tools that help energy consumers understand and get insight into their energy consumption much better. So often this involves teasing out correlated variables. It's not always clear what causes your energy bill to do what it does, especially if your primary business is doing something else, like making cars or treating patients. It can be difficult to understand exactly why you paid $300,000 for your bill last month and it was $250 the year before, or something like that. So sophisticated analytics that can look at correlated variables, maybe it's temperature, maybe it's rainfall, weather, occupancy, production rates, etc. Correlate those to specific activities, and it might be your total consumption or it might be your demand charge, but deep insight into that. So sometimes those are embedded into things like building automation systems or industrial process control systems, and other times they're standalone tools that gather that information. At the same time, you see a class of tools developed to bring in external sources. So this often involves weather. What is the projected irradiance this afternoon? What's the temperature going to be? And as a function of those two things, what is my load going to be doing? Because I've determined that temperature is correlated to my load. If it's hot, but if it's sunny, I can maybe expect my solar to perform in a certain way, letting me understand how much I'm going to have to buy on the open markets today. Bringing in other external sources such as market pricing, and together helping a consumer become situationally aware. So they're empowered when they have data and they're situationally aware, and they can begin to do things they haven't done before. Maybe it's store energy into batteries or into thermal envelopes of buildings and release that energy when cost is high. maybe that same kind of information coming in might say, look, you're about to be hit by a storm of sufficient magnitude with lightning intensity that's likely to cause an outage. Maybe you should think about turning off sensitive loads or isolating those loads from the grid proactively. So an entire suite of tools that brings in those external stimulus, cost, weather, etc., and then helps you operate your facilities in new ways. At the same time, electric utilities are being empowered like never before with tools to help them predict loading on key feeders, power quality, harmonics, other aspects that affect how they deliver energy to their consumers, and help them optimize for low cost of energy delivery, but also improved reliability metrics. So this whole field of digital tools is absolutely exploding.
Great. Thank you, Mark. Okay, we've got another one coming in here. Let me ask the question, and this one I'll turn over to you, Scott. As I understood, the utility industry failed to respond to the consumer's modern needs and provide the 21st century managed services so that consumers are turning themselves into prosumers. What's the trend of the needed changes in the utility industry?
Well, yeah, there's no doubt about that. I think part of what's interesting there is it's not just a failure of the utility per se and the industry in general, especially regulated utilities that have regulations that are basically driving their business structure, their business model, their incentives, and how they think of things, how they invest. That really, of course, needs to change. We're seeing interesting things with revenue decoupling happening, where utilities will be compensated differently than they are today. It's not just about how many electrons you sell. It's about providing a service. So those things will make a huge impact, and they're already starting. And a lot of utilities are saying, even if that's not in place yet, it is coming. So how do I start preparing for that? So that whole mind shift, the whole thinking within a utility is changing. And, of course, that doesn't change overnight, but it's changing dramatically. And it's a matter of survival. It's a matter of being relevant in this change. So it's important for all actors. And so some of the trends, or I guess you said that the changes that are occurring and that need to occur, these things relate to a lot of things. Part of it is when we think of grid modernization, it's not just investing the traditional way of hanging some thicker cable or conductors or putting in a bigger transformer or building the next big generation facility. It's about saying, how do I take advantage of the assets that I currently have and use them more efficiently? Have assets that can last longer because I'm aware of how they're being operated. And I can do some predictive analytics around how many times has this device been operated, how many times has it been overloaded. And when you have a real-time state awareness of what's happening on the grid, you can track this information. And some of this you're doing in real time, but a lot of this is post-mortem or after-the-fact historical analysis. So there's a lot of good, rich data that's available. So that's happening. The idea of saying, well, now if I'm going to invest in advanced distribution management system, well, am I going to incorporate outage management processes? Am I going to incorporate field crews and mobile applications into this? Are they going to have an awareness of the grid and where other crews are in relation to them? Where are these DER assets? Where are their potential safety concerns? So all this starts in that regard. And then you start saying, well, how could I provide service to a customer? Might it be that instead of their solar inverter just tripping off in the middle of the day because there's not much load and it's generating a lot, well, if I could use that and keep that inverter from tripping off, that asset is now utilized, the customer gets more value, the grid could get more value. So part of it really requires a whole fundamental shift in how we operate and how the whole ecosystem works.
Very good. This next one that came in here, Scott, I think you've addressed this in your previous question, but I'm going to go ahead and throw it out there if you have anything else you'd like to add, as far as what are ways for utility to prepare for these changes?
Yeah, I think we generally covered that, and that last question would hit on that some. I'll just, I guess, briefly say there are many different starting points. And it's easy. I talked to some utilities in New York that have the New York Rev and the regulations and where the government is looking to take this industry, and utilities think, gosh, this really sounds interesting and sounds good, but we're a far way away from that. And that's a real concern and an important one. And so it really is charting a flow. How do you get started? So in this presentation, I gave some examples of that. And you can do this. It's not just about doing pilots, but because that can be part of it. You might want to test different technology. But it's really starting to say, I'm going to be using network data in ways that I haven't used it before. I may have a GIS. How accurate is that data? That's a great place to start. I'll just give that one example. And looking at what do I need to invest to test that? And are there ways that I can use the system with other sensors that helps deal with some of the inaccuracies that inherently might be in that data? So looking at that and examining that for all the other things I talked about today would be great if a utility hasn't started there yet.
Great. Thank you, Scott. The next one coming in, what are the best tools available for deciding sizes of components in a microgrid system? Mark, do you want to take that one?
Sure, I can certainly start that off. The good news is that there's a lot of tools available today. Some of them open source, so that you can do some basic analysis, even free. And so some of those, being the Homer tools, other places where what are the incentives and rebates. So what interesting challenge associated with answering that question is there's an engineering answer to that question, and then there's a financial answer to that question. And that sometimes the exact size of things that would deliver the perfect technical outcome don't pencil as well as if you're willing to modify that design in such a way that it can take advantage of incentives and rebates. So I think about the Desire databases and other information that's freely available. At the same time, there is a lot of commercially focused packages available. Schneider Electric has one of those packages. At the risk of making this commercial session, I won't go into it very much. I'm happy to help with follow-ups. But there are other companies that make those available as well. Homer has a pro tool, Jelly. There's many other great companies that also offer some packages that they either will sell you the package and or do some kind of help you with the study to help you look at those things that look at the physical aspect as well as the financial and regulatory landscape to help you decide, hey, is this a CHP story? Is this a solar battery story? And if so, what's the right mix?
Great. Thank you. Well, we're getting close. We might have time for one or two more questions. So let me go on to this one. For the DER trial project, what is the recommended capacity or percentage of cable capacity of battery and distribution generation to make the result appropriate for decision-making in a way forward? Scott, Mark, which one of you would like to take this one?
I think that question, if I understand it correctly, it's wrong. Oh, I'll take one shot here, and then Scott, if I have this wrong, feel free to follow up in written email on this, and we'll dive more to it. So when I originally read that, it was talking. I thought you may be referring to the percent of intermittent renewable energy compared to the energy from other sources. So this is a common consideration when building and designing any grid, including a microgrid, that you've got to think about how to balance the intermittency of energy sources such as wind and solar with power generation and or battery storage that's able to deliver more constant voltage and frequency. And so on that regard, we've experimented with actually many different, that's often called the renewable penetration rate with many different rates. One example is we put in a microgrid at our North American headquarters, and when operated in grid mode, the renewable penetration rate's in excess of 60%. That happens to be a solar plus gas generator microgrid. So that's one of the higher percentage-wise that we've put in. And then, of course, a lot of them, there's a lot of rule of thumbs that say, well, hey, it's actually you should shoot for a much lower value than that. I think data's changing the answer to that. So If I didn't answer that correctly, feel free to follow up with an email to me, and I'll clarify it better or go down a different path.
Okay. Thank you, Mark. We have time for one last question, and so Scott, I believe this one is for you. Business case for DER group or full microgrid rely on wholesale market participation. What participation model do you support or envision?
Yeah, that's interesting. So when we start talking about DER group or full microgrid, the market participation is one aspect of it. And what model? Well, that's interesting. So I'll give you one quick example of this. So the ability to group DER assets, whether they're part of a microgrid, whether they're maybe part of an entire substation service territory, that size of grouping is much more dynamic today. So you can be much more targeted, but you can also do it broadly. You could do it by asset type. You could do it by customer program. You could do it by network location. So there's lots of ways to think about it. And then from there, you can have a coordination between what's serving the needs of the utility and any constraints they might have, and be able to participate in the market with that. And so therefore, you're going to have different programs, incentives for customers to participate and bring value to these DER assets they have. So these types of programs will vary, but they'll be able to participate in the wholesale market. We're already seeing changes in the wholesale market. For example, PJM this year recently expanded the use of demand response type capabilities to be year-round and not just for a peak load events in summer, for example. So how we think about this is changing, and it's allowing more things to be bid. So it's going to evolve.
Thank you. Okay, well, we are at the top of the hour, so that is all the time we have for questions. But for those of you who have submitted a question that we did not get to, we will definitely follow up with each of you individually. Thank you, speakers, Mark and Scott, for the presentation, and thank you to our audience for joining today's webinar. I would like to remind you that you will receive a copy of the presentation and a link to the on-demand webinar via email. We appreciate everyone's time and hope you have a wonderful day. Thank you.